So I've got a ball. I'm going to launch it upwards at a 40-degree angle above the horizontal. How fast is it going to be traveling with its max height? And also, how far did it go? If it lands at the same height from which it was launched. Ooh, 2 questions, I mean. All right, so I want you guys to do your best and pause this video. I will come back with the solutions in a few seconds. All right, so work away. And there's my nice little pretty picture. So I hope you drew a picture, because if you didn't, that could help out a lot. But 2 answers. So 1, how fast is it traveling at its max height? Well, that means that we are going to investigate what just happened here. I don't know what happened there. But anyways, so we're going to investigate what happened at the max height. So if we're going to look at right here, if you go to that part in its arc, well, at that point, it's at its max height, so its vertical velocity is 0. But it's still moving in the x-plane. So it still has the exact same horizontal velocity. Because if you draw a force diagram for any projectile, you have the only force acting is the force of gravity. So in the x-plane, we have constant velocity. So whatever velocity this was launched at, which would be this one right here, Vx, which is equal to 25 cosine of 40, that is the velocity it maintains in the x-plane throughout its path. So what that means is 25 cosine of 40 is my velocity at my peak, not 0. A lot of people bet that's 0. It's okay if you did. It's called learning experience. All right. Second thing is, how far did it travel? Well, here's how far it's going to end up. Well, how did I get that? So first thing you gotta do is make sure that you have pardon me, you've got a wonderful list of givens. So that's what I'm going to do right here. I'm going to list out my givens, if I can get this to work. And behind here is my wonderful givens. So I have my x-plane and my y-plane separated. The only thing that ever links x and y is time. So that's why that's here. And I want to figure out how far, so I listed my x-plane. All I know is the x velocity. I don't know the displacement. I don't know time. So I go to the y-plane. Well, on the y-plane, my initial velocity is 25 sine of 40. That's this piece right here. I know the acceleration is negative. Oh, I forgot the negative. Negative 9.8, because we are accelerating back down towards the Earth. If I did the net force equation for this, I'd get a negative acceleration here. My total displacement is going to be 0 because I started in the ground and I ended at the ground. Or you could say, hey, I start at 5 feet and I ended at 5 feet, because it says it lands at the same height from which it was launched. So your total vertical displacement is going to be 0. Once you have these, you can start solving. Now we're going to start solving for time first, and then we'll throw that over here into the x-plane, because we do have enough variables to solve for time in the y-plane. So let's set that equation up over here. All right, set that equation up, if it lets me. My goodness, it's like day 5. Okay, there we go. So here is my equation in the y-plane. So delta y equals v sub naught delta t plus 1/2 at squared. And when I substitute in everything into here, I solve for time. Now you might think it's a quadratic, but it's actually not. I mean, it technically is. But at the same time, you can solve it. Now, here's the way that I find that most students are able to solve it. I'll kind of quickly show 2 ways. One is you could realize you could factor out a delta t. So you'd have 0 equals delta t times 25 sine 40. There's delta t is this, plus 1/2 negative 9.8 delta t. Okay, so you could factor that out. So then this equals 0, or this equals 0. So you could solve for that. That's a linear equation. All right, that's one way to look at it. Another way you could draw it, or solve it algebraically to make sense of it, is if you took this value and you add it to the other side. So then I would have 4.9 delta t squared equals 25 sine 40 times delta t, and then you realize you've got delta t on both sides, so that can go away and that can go away, and you could approach it that way too. So kind of 2 ways to algebraically approach how to get that delta t, or you could use a quadratic. I mean, go nuts, whatever makes your day. Once you have the time, though, we are going to place it into the x-plane to start solving for that. And the only equation we can use in the x-plane is the equation for constant velocity, because, again, balanced forces in the x-plane means constant velocity. So there's my constant velocity equation. I subbed in my velocity. I took my time from here, put it down there, and so I got delta x, do some algebra, and solve. Hopefully it went well for you, and if you have any questions, please come and see me before or after class, and have fun with projectiles. Yay, physics!